JWT or JWT is an internet standard for creating JSON-based access tokens that assert some number of claims in the token itself so that it is completely stateless. In this video, I want to talk about the following. I want to discuss the good old session-based authentication because that's what existed before JWT came into the picture. It had some limitation, people shy away from it, and JWT was invented to solve certain problem. The JWT obviously came with their own problems, which we're going to address in this video. And the second thing we're going to discuss is the JWT Based Authentication and what is it, some examples, how does it really work. And then we're going to talk about refresh token, a workaround in my opinion to solve some flaw in JWT. Some people won't like that, but that's the truth, right? And we're going to talk about asymmetric JWT, another factor of JWT, encryption algorithm for the signature. We're going to talk about that. It's very, very critical. People know who use JWT to use that, especially in the microservices architecture. We're going to talk about code example, people's favorite part, where we're going to show a full-fledged application using a session-based. I'm using Postgres and Express. I'm going to provide the source code that I wrote, and I'm going to write using JWT, so rewrite it in a bit using JWT. And I'm going to use refresh token, access tokens, all that stuff, right? So, and as I talk, guys, you should start seeing some time codes where you can jump into the interesting part of the video. You don't have to watch the whole thing, obviously. And finally, pros and cons of JWT, because guess what? Nothing in software engineering is perfect. Everything has a pros and cons, and you as an engineer, you assess your use case and pick what is best for you and nothing else, right? Never get attached to a technology, all right? If you're interested, stay tuned. If you're new here, welcome. My name is Hussein, and on this channel we discuss all sorts of backend engineering, really. And if you're interested to become a better software engineer, consider subscribing and hit that bell icon so you get notified every time I upload a new video. With that said, let's just jump into JWT. First thing we're going to talk about, session-based authentication. Good old stuff. We have a beautiful database here. I have a reverse proxy load balancer here, and I have my application that does the authentication, right? I have two services running here. We talked about this many times. I'm going to reference the load balancing videos if you're interested to know how this works and all that stuff. And the client want to log in. And in the Postgres database here, or MySQL, any database really, I have a table. I have a username, and there is a password, and there's a role. Password is obviously not plain text here, but consider it's bcrypted, hash, salted, all that jazz, right? And I made a video about the password method of storing what is the most, from least secure to the most secure. Go check it out, right? However, we have the password stored here. So, and there is a user who says, I want to log in. Look what happened here, right? I'm going to do it again. Make a request. So we went to this server first. And that server took that request, which is post request to log in. Edmund want to log in. And that's the password, testing 1, 2, 3. And you might say, well, you're sending the password in clear text. That's absolutely fine, because this puppy and this puppy are in a session which is called TLS, and they are encrypted already, right? That's hence the 443. Okay, so that's okay if you're sending the password plain text. Everybody's doing that anyway, right? So, but technically it's not a plain text, it is encrypted, right? So when sending that, I get the information and I authenticate. I know that the user is good, and what I do, I generate a big large random string and I store it in the same table or in any other table, right? I'm called session ID, and with the session ID I'm gonna store as much metadata as possible. The username, the role, who is he, an admin, is he a normal user, when does this session expire, when was this user logged in, last logged in, every possible information you stored it there. Beautiful. And now what we do is just return that session ID back to the user. Say, hey user, this is your session ID. What does that mean? That means, since we are on a web architecture, you are responsible, sir, to send me this session ID with every request. Because guess what? The HTTP is a stateless protocol. That means you make a request, right? And we know who you are, but the second request you make, we have no idea who you are. It's a completely stateless because that request could hit this server, could hit this server, could be completely another server, right? We don't know who you are, so you need to identify yourself with every request. And that's what the responsible of the client. So the client, what it does, says, yay, I want to say hello. This is a new REST endpoint. And here's my session ID. How do I send it? I don't care. Send it via cookies. Send it via auth header. Send it as a post request. Send it as a get parameter. I don't care. You can use any method. There is pros and cons of each one. Well, as long as you send it to us, we will take that session ID. The session ID by itself doesn't have any info, right? How do I have the information? I query the table. That session ID says, okay, who is this guy? And I find that, oh, it's Edmond, and this is an admin, and this is expired. Okay, it's not expired, so authenticated, good. So you don't have to send the username and password with every request. Just sending the session ID, I know you. Well, there is an extra head to the database with every request you make. Well, and then you send me back, hey, hi Edmond, you're good. I know I authenticated you, right? That is pretty cool. So what happens if I send another request? We go to another server, and that's absolutely fine, okay? And that also works. We send you hi. And I wanted to explain that because there's a lot of misconception that session-based authentication is actually stateful. Well, yeah, yes, and no. Well, it is stateful as a system because I am storing the state, which is the session ID, in the database. However, my application is clearly stateless. That's because I can destroy one server and my application will be still running, right? The client will not be forced to log in. I didn't lose any information. This guy can die, this guy can die, and they can resume. If there's a new server, they will absolutely resume as long as the database exists, right? So the database is the state. The system is stateful, but the application is stateless. I want you to know there's a very, very good, important information to understand here, right? Yes, so it's not full. Yes, it's still a stateful system, but it's a stateless application, right? That's why it scales here. And you can make this as a primary kind of backup, replicated the database, so it can scale horizontally as well. All right, guys, so that's the session-based authentication, right? What's the problem with this? Well, every request I make is actually taking extra latency to verify by these applications to query the database. And that's an extra hop. And that's an extra, it takes time, right? Even if it's a Redis database, even if it's a Postgres, there is an extra latency. People didn't like that, right? So some people came up with other solutions, says, okay, we're gonna cache information here, right? We're gonna query once and the session information will be cached here on here. But then you make your application stateful, right? And people didn't like that because, okay, how do I know that this information is up to date? Because the moment you store this here, you're out of sync, right? Because the session could have been hijacked, right? Someone hijacked the session, and then, you delete that session, but this guy has a cache of it, right? You get this inconsistent state, and that's bad, right? There are a lot of ways to solve this, but I'm not gonna, this is out of scope of this video. We're gonna talk about it maybe in another video, right? What people invented was JWT, so JSON Web Token. It stands for JSON Web Token. It is a completely stateless system. That means we want the application to be completely stateless and the whole system to be stateless. That means if I take that JWT and give it to a completely different service that has no access to my database, it will be able to authenticate that guy. All right. How do we do that? Magic encryption. three parts. It has a header and it has a data and a signature. I'm sure you're sick of listening to this, so I'm not gonna go into details about this, right? So there's three parts of this where the header, it tells you, oh, this is an algorithm, the signature has been encrypted by this algorithm, and there's the data, the actual username and role, right? Put it in the token itself. Don't store it in the database, right? But the moment you say this, oh, Hussein, if I put it in the data, if the token itself, as a user, I can make myself admin, right? And I just send it over and I'm an admin. Well, no, because that data will be verified by a signature that only the server can verify, right? So the signature can be either symmetrical or asymmetrical. We're going to go through that. The symmetrical, we talked about symmetric and asymmetric encryption. I'm going to reference the video here, guys. But in a nutshell, you take a key, you encrypt the data, and you store it as a signature. And the same key can also decrypt, right? So symmetrically require the same key to create and validate the token. Asymmetric private key, right? That's the asymmetric part where you can encrypt with a key, but decrypt with another key, right? Encrypt with a key and validate with another key. The validation is public, and there's like a pros and cons for using each of them, right? We're going to go through them. People favor this more than this, and we're going to talk about why. Here's how it looks like, right? And in my example, Edmond Dantes as a name, as the user, and this is the role, and this will expire at, right? And you, as a server, you build this token, right? You build this payload, and then you say, hey, I'm gonna encrypt it with this algorithm, which stands for HMAC SHA-256, right? So what we use, this algorithm is to encrypt this content and put it there. So this is exactly the verified signature. And to do that, you need to provide a secret. And this secret is the symmetric key that we talked about. Symmetric key because we used a symmetric key algorithm function here, right? If you use an asymmetric key like a RSA, then you provide a private key to create the token. To verify, you provide the public key. And the public key can be shared. We're going to talk about that in a minute, right? But that's it. The secret is known for the server. The client never knows the secret, right? So you store the secret. And here's the first kind of problem of this, right? Secret keys, right? Where do I put this key, right? All right, let's take an example. How does this work? I'm going to log in. Same exact thing, guys, right? Post login, Edmond, testing 1, 2, 3. Again, this guy is encrypted. Remember, this is a TLS, probably, right? Has to be TLS. And then it goes here and says, oh, Edmond testing, good. Let me query the database. We still need to query the database, right? We're authentication. We have to store the username and password somewhere, right? Okay, I know. I validated you. You're good. We query the database. Now I know you, right? Let me generate a token for you. And here's how we do it. We create a JSON, name, Edmond, role, admin. And if you have attributes, as much as possible, put it there. Don't put sensitive information because this will be public. This token will have all information. Put the things that you don't really care the user can see, right? So they can see, but they cannot do much about it, right? So you put the information there. And then you take the symmetric key, the secret, right? And that the secret, which knows by the server and have to be all known by also this server, right? You encrypt that with that JWT library, and that will generate a huge string that consists of 3 parts that we shown earlier, and then you return that token to the user. Same exact scenario as the session. You are responsible to send me this token with every request. I don't care how do you send me this token. Authentication, bearer, some people do that because of APIs, token, cookies. Probably best way is to do it as HTTP only cookie and strict and same site strict, and if you want to be even more paranoid, make it secure, right? And you send it. I don't care how you send this token to me. And here's the thing. Do you see what happened here? That's it. We didn't hit the database. We only hit the server, and the server immediately verified that this guy is Edmond. And how? Here's how. Because it has the same key, the golden key, which is the symmetric key. The same key encrypts and decrypts. So I'm gonna take that token. I have the information. I didn't decrypt anything. It's right there, but I just want to verify that the token is right. So I'm gonna compare it against the signature part, and if it's good, the library tells me that's good, looks good, I'm gonna trust that, and I'm gonna respond back, hi Edmund, I trust you. I didn't even have to query a database to trust you. And that is so powerful, guys. So powerful. This is a truly stateless system. I can take the same token and I send it to anybody who understands how to verify JWT, and they will be able to verify themselves. That's why OAuth 2 is a big thing, right? I can verify with Google and they will give me a JWT, and then I take the JWT and I absolutely can verify it, right? Until it expires, obviously. So it's a completely stateless system. People loved that. It comes with a price. Nothing is free, right? So what do? That's the problem. That key, that same dang key, I have to share it with all my services, right? People who want to create secret JWT tokens and services that want to verify have to know the key. But the moment you share that, there's a problem right now. Okay, we'll go to another example. Here I hit another server. Doesn't matter because that server has the exact same code that verified, and then it will respond back. And here's where it breaks down, guys. All right, guys. So I might not trust the other service that I want that token to be authenticated, but that's another problem we're gonna talk about later. But what's wrong with this, right? What is wrong with this particular token? We're going to talk about refresh tokens, but what is wrong with this? Once it's stolen, we can't do anything about it, guys. Yeah, if it has like 100 days expiry, enough has been stolen, now we can quote unquote define what stolen mean. I mean, this cannot be stolen between this guy and this guy because this is encrypted, right? So the only loophole here is, well, I take it back. If you be a man in the middle, then that man in the middle attacker served you the certificate, they can somehow capture that, but that's extremely unlikely. And if you don't know how to verify the certificate, then you probably went to the situation, but extremely unlikely. Let's take the more likely solution is that guy here in the browser or the client itself got attacked. XSS, cross-site scripting is a thing. Cross-site request forgery is another thing, right? They are going away. At least the cross-site request forgery with the same site cookie, introducing a same site cookie, they are going away. But cross-site scripting is a thing. So once you stole it, if someone stole that token, they can present that token to any service and they will absolutely be verified. Because guess what? You cannot say, hey, this token is no longer valid, I'm gonna destroy it. Nope. There's no database. There's not in the session. If the session was stolen, you go to the database and you truncate your session, you delete that session ID, you're gone. You're done. That session is destroyed because there's a central location where the truth lie. This is a stateless system. If it's stolen, tough luck. You cannot do anything about it. Everybody can just take that token and then verify themselves. There are so many ways to solve this problem. One way is refresh token. Another way is to add some state to your stateless JWT token. I'm gonna talk about those. Okay, and so what do? People said, okay, this access token thing, which is these tokens, let's make them short-lived. They have to be short-lived because if in case they are stolen, right, what we're gonna do is they're okay, stolen. It's again the fact that they are, we say stolen in a very light way, but it is really hard to steal tokens, guys, right? Because stealing tokens is not just something you do. You cannot sniff in the middle. This is encrypted, right? And the second thing, carrying out XSS attacks is extremely well crafted. It has to be well crafted to actually nail it. So And yeah, it's not that easy. But if someone managed to do that, we want to make this token as short as possible so they can only access, I don't know, 15 minutes, right? Whatever. But the moment we make it short-lived, we're gonna, let's say 15 minutes, we're gonna tell the users, hey, users, your token expired, log in again. That's very bad user experience. We can't force users to log in every 15 minutes. That's just dumb. Well, banks do that, and that might be a good idea. But imagine if Facebook forced you to log in every 15 minutes. That's just dumb. So we need a way to get a new JWT token every 15 minutes. Thus, refresh tokens were born. And what are refresh tokens? They're exactly like sessions. Yes, I said it. This is exactly the same thing, right? When we brought it we added some state to it. So a refresh token is a JWT token that you store in a database, right? And still there is value to this, guys, right? Still there is value to this, and we're gonna talk about it. So let's go through our same exact scenario, but with a refresh token. I'm gonna log in. My name is Edmund. This is my password, all secure and jazz. I hit the server and I authenticate myself because I had the database. I have to check the password, right? And then what we do is we generate two things. We use the symmetric key, right? Once we verify, we use the symmetric key here. We generate an access token, which is short-lived, like maybe 10 minutes, 15 minutes. And then when we generate a refresh token, usually it's usually doesn't have expiry, right? But if you want to make it 1 day, right? And then this is longer, and we return both to the user, right? Here's what we do. We return both to the user. Token, use this to authenticate every request that you make. Use this in case this guy's expired to generate a new one, okay? We'll talk about that. And here's what we did here. We stored the token in the database itself, exactly like we did with a session. Yes, I stored in the same table, but you could store it in another table. And by doing that, we kind of played like a session in a way, right? We're going to talk about an example here. Let's see what's going on. And here's another thing. This, you can put in a cookie. This, you need to store it securely because this could be attacked by XSS and CSRF, and they could be stolen. If they are stolen, then you're absolutely screwed, right? Because if this is stolen, that's okay. But if this is stolen, people can take it and just create their own tokens from it. But we're going to solve that problem as well, right? So let's see. What will happen with the refresh token? I log in. And obviously, we don't hit anything in the database. I am verified. And then we take that. We verified all that jazz. Good. But the token has been expired. What do we do? All right, so my token has just expired and I want a brand new token. But prior to expiry, I gonna generate a new token. So it's a client responsibility to get a brand new access token. How do we do that? You make a post request to an REST endpoint and you specify the refresh token. I don't care how, right? Probably the securest way is to put it as a part of the authentication header here, right? Or the body, right? Not as a cookie. I wouldn't do it as a cookie, to be honest. But regardless, once you do that, look what happened. And we hit the database. We have to. Despite the refresh token being stateless, I could have verified it with my symmetric key, right? But we don't want to do that. We have to hit the database because guess what? This could be stolen. We don't know for sure. We need to hit the database and verify that the token is still valid, verify that the token has not been blacklisted maybe, verify that the token has not been stolen, and all this information, right? And this is now became a centralized system, but it's still better. It's still better than session authentication, guys, right? It is still better because with every request, I don't have to hit the database. Now I have to hit the database only with after 15 minutes. That's absolutely fine. That is really, really good, right? So now I'm going to give you a new token and this will return basically a brand new access token. The client is responsible to use this new token with every request. I'm going to show an example, coding example, hopefully. Right, guys? So that's the refresh token. Wow. All right. Then obviously, as we said, I'm going to use the new token, the access token, to access. And since this guy have my symmetric key, they can verify it and they know who I am. The only trick here is the client is responsible to generate this new token. So we put some work on the client, right? Something we didn't have in the session ID, right? So it's a pros and cons game you playing here. We're going to talk about all of that stuff, right? Really, there is no favorite, to be honest, right? You can go with each one, depends on your use case, again. All right. Sharing secrets, guys. How do I share secrets in a microservices architecture with JWT? We have this thing now that is called secrets, right? Because yeah, it's a stateless, but guess what? Nothing's free. I need your dang key to authenticate, right? But the moment you share that key, right? If this guy's like, okay, I'm verifying, I want to hello2, service hello2, service B, right? Want to authenticate this token, you gotta give it that key. And the moment you give it that key, this guy could be evil. And if this guy is evil, they can generate their own token and they can make it unexpired, right? And they can just authenticate on your behalf. That is absolutely bad, right? So absolutely very rare that people use symmetric key in microservices architecture, especially in a zero trust architecture where nobody's trust anybody in this architecture, right? So what do? Meet asymmetric JWT. Again, guys, watch my encryption video if you want to learn more about symmetric versus asymmetric. But in a nutshell, symmetric encryption is you encrypt with the same key and you decrypt with the same key, right? What does that mean? You encrypt with a key and you decrypt with the same key. And it's absolutely powerful and fast. Asymmetric key, you encrypt with a key and you decrypt with another key, right? Or you encrypt with a key and you verify with another key, all right? So it's asymmetric. And there's pros and cons. We need both to make encryption work and security work. We cannot handle just one. Kerberos authentication actually just work on symmetric key in a very smart way, right? And I love that. I really love that. I'm gonna make a video about Kerberos. Comment section below if you want to see the video about Kerberos. It's an old technology, but it's so badass. All right, asymmetric. Back to the topic. So asymmetric JWT or JWT, right? The authentication service is only service that has the private key, right? And you can use it to generate these JWTs, right? But to authenticate, you use the public key, and you can give this away because this key is useless. It will only validate. It will never be able to generate new keys. So, and to do that, you just use, for example, an RSA, right? You gotta be careful with this because asymmetric algorithms are slower than symmetric algorithms. And if you have like a big JWT, I don't know why would you have that. Asymmetric is absolutely slow with big data, not big data, big data. You get it. All right, guys, coding time. Let's jump to the coding, and then we're gonna jump in and pros and cons of JWT. How about we do that?
All right, guys. So initially, I wanted to actually live code this one, but in favor of time, I noticed that the actual content is now 50 minutes, so I don't want to spend more time just showing you how I code this. So I have the source code. I'm going to explain it to you how I actually wrote it. So how about we actually show the session-based authentication code that I have, and then show the JWT version, and then we're going to go through the code and how exactly I did it. How about we do that, right? I apologize for that. Maybe I'm going to make another video to just live code and how I actually do that. But if I do this, I'm gonna take me another maybe 40 minutes just to write the code from scratch. So I apologize for that. So what we have here is a session-based authentication, and this is backed up by the Postgres database, and here's the table. It's called Sesh-Auth, and it's empty. It has a username, password, role, and session ID. Okay, so what we're gonna do here, I'm gonna create a new user called test. The password is also test, and I'm gonna register him as a normal user. And if I do that, the moment I do that,
the password is I'm using bcrypt to encrypt all of that stuff in the password. This is the test, and this is now a user, and there's no session because this user didn't log in technically. What we're gonna do is we're gonna submit a login. So that was the register endpoint. This one is now the login endpoint. And if I do a login, I'm gonna get back that this user has logged in successfully. And here's what happened here. When I query the same thing, I now have a session ID. Look at how long is this thing. You can make it as long as you want. The longer, the better, the more secure. And look what happened here. And look what will happen here. Since as part of the login, I set a session ID cookie, right? And this cookie is on HTTP only. That means it will never be accessed by document.cookies. So it cannot be accessed by JavaScript. So it can only access by the session and only HTTP only. So it will only be sent by HTTP. And I made it lax, right? Same site. I talked about same site cookie. I'm gonna reference the video here, guys. But if you can make it strict, is even better. But lax is good. So now, the moment I refresh the page, the cookies will send the session ID, right? Because that's what cookies does. Whatever request, they automatically do that magically for you. Look what happened. The page has changed and now it's greeting me. What is up? Hey, you are a user. And there's a button to log out. And the page is blue because that's how a user. If I'm gonna log in as admin, I'm gonna show you it's gonna become red. Just showing you their functionalities, right? So now I can automatically also log out, and what logout will do is literally null this thing out. That's what it does. And next time if I refresh, I no longer know you. So that's how session works. Very simple. I'm gonna show you the code, and the code will be available in the description below, guys. It's exactly how I did it, right? So that's the logic. Let's log in as an admin. I'm gonna register a brand new admin user. If I query, now I have another entry, and it's an admin. How about we log in? We get another session ID. All right, that session ID. Now we'll have the admin session ID, right? And if I refresh, look at that. It's now I am admin. Hey admin, what's up? You're an admin. That role is admin. So I use this like kind of a edge side includes, right? To render this HTML. It's not really edge side include, but very similar thing. I render this the HTML on the server and ship it to the client. All right. So and then that's it. That's admin, and you can immediately log out, right? And it works. The moment you log out, that's it. You're done. So here's the source code, guys, and you can see with every request, we have been validating the session by querying the database, right? And here's the source code. It's really straightforward. I'm using pool PG node PG, which we have talked about in the data in this channel before. I'm using a connection pooling to create multiple connections, and every GET request to slash, we need to validate the session ID. If the session ID is there, then go ahead and validate the session, which is nothing but a query to the database where the session ID exists. If it exists, if it doesn't exist, return null. If it exists, return the information that we found from storing the user from the table itself. If it's valid, if it's not valid, you're gonna go null, then send back the login page. If it's valid, go ahead and read the user.html and change these things so it reflects the user page. That's exactly what I did. And I'm sending back the user. And I'm just changing. If it's admin, do this, light blue and color blue. So it's readable. The code is very readable. It's very simple. But login page is actually querying the database and doing the password authentication that we talked about in another video. And it's just sending back the session. All right. Let's do the JWT. I'm gonna stop this, go to launch, and change this from session to JWT final and JWT auth. I'm using MJS because this is the new standard now, and technically air quotes, you can the same code should run in the browser, not exactly, because these are unavailable in the browser, but you can write a library like this that use import and have it execute on the browser, as long as it makes sense. You cannot query a database from browser, obviously. All right, refresh. JWT based. Let's go ahead and just clear all the tokens and cookies that I have, right? Boom. Let's just clear this guy because we don't really need it. So for JWT, it's the same thing, but we're gonna query another table called JWT Auth, and it doesn't have everything now. It has a username, password, role, and token. This is for the refresh token, right? But what we're gonna do here is, let's create a user called test. Register as admin. Oh, I wanted to be a user. Never mind. Now this user is now an admin, all right? Same thing. So far I didn't use JWT. But when I log in, here's what with the user here's what the server will give me. It will give me a JWT. This is the JWT. It give me actually two things. It's gonna give me the refresh token and the access token as well, which is awesome. So the access token has been set as a cookie, right? And the refresh token, I stored it in the local storage. So this is the refresh token, right? So I stored the refresh token in the local storage, but the access token is in the cookie because it's more secure to have. You don't have to send the refresh token with every time. I mean, you can, but it's kind of useless, right? So you store it, and whenever you need it, you refresh in order to recreate a new token, right? So how about we actually refresh this thing? Here's the thing. The access token that I got is only 30 seconds, I believe. So if I log in, if I refresh, you can see that I am logged in, right? But when I go to the console, you can see that there is a process that is renewing my token I believe every 30 seconds. That's how I did it, right? Because the token actually expires every 30 seconds, I have to renew it every time, right? Otherwise, I'm gonna get the page, right? So every time now, I can keep using this token, right? But once it's expired, right, the cookies will be updated with my new token, right? JWT token. And that's it. I'll be logged in forever. That's the idea. All right. That is pretty cool, huh? Now, let's take an example of how you actually can log out, right? If I refresh here, by the way, you can see that the refresh token is stored here, right? And I'm logged in as far as I know, but every now and then I have a script in this page that actually generates a brand new access token so I can continue working, right? But how do I log out? If I hit log out, what will happen here? We nulled out this thing, but since I still have an access token, I cannot do anything about it. That will still be valid until the 30-second is up, any second now, and you will see that this page will go away after a while. There you go. You notice, right? So now the access token has been logged. So that's kind of a bad thing compared to the session. The session that immediately I logged out. With access token, the idea of logout doesn't exist, guys. Because how do you log out? Log out is technically means take me out of the session, make my token invalid. And how do you make your token invalid? There's no way. The state isn't the token. It's too late. I have to generate a new token for you. I have to store the state that this token is logged out somewhere. And the moment you do that, it's a stateful, right? So the only solution you can do is this that I can think of, to be honest. Log out, you have to wait. You kill the refresh token, essentially. All right, that's how you log out. All right, let's go through the code. The JWT Auth, very similar things I used, except the JSON Web Token I'm using for JWT. Cookie parser, I'm still using all that stuff. I'm storing the secrets for both the access token and the refresh token in the code. Bad idea. Never do this, right? Use it, store it as an environment variable or in a key management, right? Do you have a key management system if you want to use this stuff? Yes, it comes with a price. JWT is not free. So yeah, so you have this information and pull to query the database, get request, give me this JSON token, JWT token, and if the token is there, I'm gonna validate the token, and this is not a query to the database, just give me the secret, and I'm gonna verify, JWT.verify, give me the token, give me the secret, I'm verifying it. If it's good, I'm gonna return it. If it's not good, it's gonna return null. There is no query to the database. That's an inline verification, and it's pretty fast, right? Not much if you have a big tokens, so be careful of that. I don't know if that has a limit, guys. Let me know if there's a limit to JWT's token size. I don't think there is. But yeah, if it's null, that means send the login page is no longer valid. That's what we saw, right, when we kept refreshing. And if it's valid, go and read and change everything, like same code we did with the session, right? Make an admin roller, all that jazz, and send it back. Else, if the user as the user has the login, this is for the refresh token /token. That means every time you post a request, right? I'm gonna validate the refresh token using the refresh secret, right, token, and then if it's not valid, I'm gonna return. Else, I'm gonna query to see it's valid, the refresh token is valid or not, and if it's not valid, also fail. If it's valid, go ahead and just return a brand new access token. That's how we re-sign it. And I'm using the HMAC SHA-256 to generate the token, set the token in the cookie, and that's it. You send it back. So that perfectly works, and this is the login. So all the code will be available for you guys here to play with it, right? Obviously, this is not the best practices, to be honest, right? The best practice is to use a vault or key management to store all the cookies, but the same idea holds. The only bad thing about this is just the storing of the keys here, right? Some people use environment variables, but you have the same problem. Where do you store this environment variable? Where do you come up with the keys, right? You can put in the code a lot, because if you store it this way, you're pushing it to your Git repo, the code, the secrets in the Git repo. That's bad. You don't do this, right? So you mainly store it somewhere else that is not accessible to everybody. All right, guys, so that's it, really. I'm going to push the code for you guys, and then here's the create SQL to create the tables if you want to spin up your own. If you want a Postgres database, it's really simple. Check out my Docker video, because I spin up a Docker Postgres. It's just like in a few seconds you have a Postgres running. So you would clone this and npm install and all that jazz, and we'll do all that stuff. All right, guys. Go back and talk about pros and cons. How about we do that, guys? All right, guys. So that was the coding part. How about we finish this video by talking about the pros and cons of JWT? Because nothing is perfect, right? It really depends on the use case. So let's start with the pros first, guys. The first thing, a pros, and is absolutely a great advantage for JWT, is it is stateless, and it's a completely stateless system once you use it, because you can throw this token in every service as long as the service has the secret key or the public key. In that case, it will be able to authenticate that without hitting a centralized database, right? At least for just the access part of it. Okay, so the access tokens, they are beautiful for stateless. Yeah, for refresh tokens, there is some sort of a centralization, right? Because now you have to hit the auth service again to get a brand new access token, but nevertheless, right? So it's great for APIs because of this, right? Now I can talk to a central authentication service, right? And I can build my own API, and then everybody, right, if they want to authenticate, they talk to me, they get a token, and they can build their own application, and they use my API. As long as they provide that API, right, that token, they can be logged in. If you build another REST endpoint or another GraphQL endpoint, you can use that JWT to authenticate yourself without relying on a centralized database, right? And that scales very, very well for APIs, right? People all the time use this, right? It's very, very secure, right? Because the security of it is because I have everything encrypted in the database, in the token itself. It's very, very hard to actually break it unless you use the very weak secret or a very weak key, symmetric key or private key, that is, right? So it's secure, right? So people rely on them because of it's secure. It carries a lot of useful information that doesn't really require us to query the database to obtain them. And that is so powerful. And you can trust this information because it's secure. Back to the security, right? Now, right, in a session-based auth, you have to only give the user the ID, right? That's it. You cannot give the user the actual username in a cookie. You cannot trust that. Or you cannot give them, hey, by the way, this is your role. And you rely on them sending that to you. No, that's a bad idea in a session base because they can just change that and make themselves an admin, right? Go to the cookies and the dev tools and change themselves to be an admin. You never do that. So you only have to have the session ID. And when you do that, you have to store the information on the server. And that's an extra hop, extra latency that can slow you down if you have a lot of requests. So it's very useful to have everything in the token itself. So that's even the experience in the page, right? You can render pages in JavaScript on the client without having to rely on the server. Hey, you have the JWT, you have the username, you have everything. You don't have, user or server. What's my What's my username? What's my admin credentials? No, you cannot do. You don't have to do that. All the information is in the token, and it is available for you. It's not. Let's be very clear about this. JWT itself is not encrypted. It is signed, right? So the text is a plain text. This is base 64, but it's a plain text. You can actually read it. The signature is encrypted, right? So you can actually read this without needing to decrypt it, to be honest. And as we said, right, can store information that drive user experience, right? You just use that information and drive the user experience without relying on the server. Very powerful. And we don't need a centralized database anymore to authenticate ourselves, right? This is a beautiful way, just stateless, right? Take that JWT, hit it somewhere else, and you're good. You're golden. Okay, we ran out of pores. How about we talk about cons? The cons. Sharing secrets in a microservices architecture, right? And you guys, when I made the YouTube stories, you told me how much pain in the ass this is, right? If you have building a microservices architecture and you're relying on JWT, that dang secret, even if it's an environment variable, you have to share it somewhere with all your services. If you're using symmetric key, that is, right? And that's a problem, right? Because the moment you use that, then sharing secret becomes really, well, where do you put the key? Or do you put it in a database, right? Or put it in a central authentication service, right? Like Vault, you can use Vault to do that, and Vault's pretty good, right? Storing all this secret management. Becomes all this secret management, it's actually its own problem to solve. And Vault, from HashiCorp, I believe, they solve this problem very elegantly. So sharing secrets is a pain, right? Sharing keys is a pain. And the other problem is, even if you use private key, which says, okay, I'm going to share the public key, but where do you put this public key, right? And how do you know that this public key is still valid? Let's see, the private key of the token of the service has been leaked somehow, heartbleed, I don't know. And then, people started generating their own token, and then the pairing public key is no longer valid. And if it's no longer valid, old requests should be stopped, right? All tokens are just done. How do you do that? How do you deprecate a key? Well, you can say, okay, let's just delete that key and use this public key. But what do we do with that old tokens that they are still valid? Do you trust them? Or do you say, no, guys, we don't trust anything before that date? All these all these JWTs that have been created with this old key, no, we don't want it anymore, right? So key management is a pain. Where do you put this public key? It's kind of back to, you still have this latency with key management, right? Because you're gonna either put it in a microservice, authentication microservice that rely on key management, or you put it on Vault, or you put it somewhere, you have that extra latency to verify the key. So it's kind of back to the same problem with the session, which is that extra hop, right? You cannot escape that. Yes, it's attractive, but that problem still exists, right? And it's painful. I'm going to reference a video, guys, for one doctor's named Philip. I forgot his last name, but he's very, very, very good presentation talking about the bad practices with JWT and bad things that did with that. So key management is a thing, and people's trying to still solve this problem. It's very tricky to consume correctly. I didn't say implement, but consume. The client is now responsible to deal with this access token, and it needs to know where exactly to send it, whether it's whether authentication as a bearer property, or whether as a cookie, or whether as a post request. And when it knows that, well, it needs to know that, oh, this token is about to expire. Let me generate a new refresh token. And it needs to build this token in itself, which is annoying. We never had to do this with the session IDs before, right? If the session is expired, it's expired. If the session is not expired or is stolen, tough luck. The admin goes to the database and say, oh, this session is done, I guess. Let's delete it. And the next request will just invalidate that session. So it's very simply, elegantly designed previously, right? Yeah, there is this extra hop which we can solve with a little bit of statefulness in the server, but yeah, still you're adding some extra complexity to the clients, right? Nevertheless, it is complex and tricky. I'm gonna say complex. It's tricky, right? Again, guys, if I'm saying anything that doesn't make sense, let me know, because I don't know everything, right? I know what I read and research, and every day from you guys, learning input, watching other videos, and implemented it myself. That's what I find. It's just completely my opinion, right? Prove me wrong. Let's have a discussion, right? And then let's just say, what's your best method of authentication? Really, there's no best or favorite method. It just really depends on the use case, to be honest. Storage of refresh tokens. Now we have the same problem, right? The token is a precious. Access token is not that precious. You can put in the cookie, right? Because it's just short-lived. But the fresh token is long-lived, and if this is stolen, it's a problem. So where do you put it? You put it in the local storage JavaScript like we did. That's susceptible to XSS attacks, cross-site scripting. What do? You encrypt it? What do you encrypt it with? A key? Where do you store the key? It's the same problem. It's a very hard problem, guys. People are still figuring this stuff out. It's a very hard problem. You can store it anywhere you want, right? I would prefer as an index DB, because index DB has a little bit in the database has a little bit of more security than local storage, to be honest. But index DB's API is bad as F. Token, revocation, and control. Same thing. Token. This guy, whomever we issue this access token or refresh token, turns out to be shady, and shady people deserve no more access. How do we revoke that? Tough luck. You cannot revoke a JWT. JWT is stateless. There is no. Where do you store the state that, oh, this is no longer valid? Where do you store this? Database somewhere, right? You can say, okay, I'm not gonna store in database. I'm gonna store in the authentication service. Yes, then this authentication service has to store it in a database, obviously, guys, right? So yeah, take token revocation and control, like who has access to what. Oh, this token is still valid, but this guy cannot access this resource anymore. This cannot access the pictures because, I don't know, he's doing something shady. We don't want him to access the pictures, but they can still read the comments. I don't know, something like that. So how do you revoke control, right? How do you do this stuff? Back to the centralization. With session IDs, you can still do that very easily because it's a centralized design, right? With this decentralization, I'm not sure that decentralization is the right word, to be honest, but the statelessness, that means the state is in the token all the time. We have no way to change the state in the token, right? It's there. So it's a very tricky problem to solve. People are still doing it, right? You can still have asynchronous calls on the server that periodically check the state of the token. I would go with that method, to be honest, even with the session ID, right? You don't want to hit this database every time with each session. You store something locally and you poll it every, I don't know, 15 minutes or so and check the latest state. So you're fast when a request comes in and you don't basically take the hit. And there is the insecure implementation of libraries. That I took this point actually from Philip Direk. I'm gonna put his Twitter below, right? So in his presentation, he talked about some of the insecure implementation of libraries, right? So it's like, what happened if you put none as the algorithm in a JWT, right? That's a perfectly valid token, and people did that, right? And if you did none, that means it's not really encrypted. That means the signature is empty. That means I can just make up my own JWT and I pretend to be an admin. I claim to be an admin. I know I didn't use that word a lot, but that's what JWT does. It claims, right? I'm claiming to be an admin, and you're gonna believe me because your library support none as an algorithm, right? Because there's no encryption, there's no signature. So yeah, it blew me away when I read that. It's like, what? Some library did that, and it was there until 2015 when somebody actually discovered it. It's like, what? Yeah. So do you trust the libraries? Maybe, right? What do you think? JWT or no JWT? What love do you give to it? Right? Session IDs, good old session IDs, because you're whole old school 90s kid, or you're hip, you're 2020 kind of a guy or gal that likes JWTs, right? I'd use JWT, to be honest. It's a beautiful design, right? And to be honest, I'm not gonna use refresh tokens. I think I don't think they are necessary. I would just use access tokens, right? And here's what I'm gonna do. I'm gonna use access tokens, right? Only access tokens. And what I'm gonna do on the back end, I'm gonna store the access token. I'm gonna make access token unlimited. There's no time limit to it. And I'm gonna store the token in a database. And every 10 minutes, asynchronously on my server, I'm gonna poll the database and say, hey, is this token valid? Is this token valid? Is this token valid? So that if the token was stolen, I know that's stolen because maybe I got request from another IP address that I'm not supposed to, or has been reported to be stolen. I just go to the database and delete that entry. And for the next 15 minutes, the attacker will have access to that token, but after that, they will no longer have access because I'm going to delete that. The server will discover, ooh, that's bad. So I would do it this way, to be honest. But that's just me. I think the idea of refresh token is really unnecessary, to be honest. I just find it really, it's just, wow. Why do you put the blame on the client to do all the work, generate a new token and everything? It's an extra, I don't know, extra complexity. I know Auth 2 does it, and there's probably a good reason for it. I still don't understand it because there's better ways of solving things, right? But that's just me. Might be wrong. All right, guys. That's it for me today. I'm going to see you in the next one. You guys stay awesome.